Today we're going to be looking at two processes, one called annihilation and the other called pair production. Essentially, these are basically the opposite of each other, and these occur based on how matter interacts with its own antimatter. Now, before we go on, I'm going to introduce you to the concept of rest energy. Now, it was Einstein that said that the energy of a particle at rest is given by E equal to mc squared, a formula that is very, very popular. And what this equation basically shows is the equivalence of mass and energy. It shows that the mass of a particle can be converted into energy, and the amount of energy that is going to be released if you convert all the mass of this particle into energy is given by the formula mc squared, where c is the speed of light. So the total energy of a particle is just given by is rest energy, which is mc squared, plus its kinetic energy. Or you can write this as mc squared plus a half mv squared. So let's look at this process called annihilation. Well, what it is when matter collides with its own antimatter, something special happens. And what happens is the particles annihilate to form two photons. So let's say you had this proton and this antiproton. If these two were to collide, what's going to happen is the total energy of each of these particles is going to get converted into two photons, one in either direction to conserve momentum. And when I say that the total energy of these particles gets converted into the photons, that's including the mass energy. So the kinetic energy of each particle and the mass energy combined gets converted into these two photons. So let's say this proton and the antiproton, when they collide with each other, somehow have a speed of 0 meters per second. Using the mass of a proton, which you should have in your data booklets, you can work out the rest energy of that proton. Now, I'm pretty sure that for some examples, the rest energy of a proton will also be given. So you can use that value directly. And in this case, it will be, I think, roughly 1.5 times 10 to the minus 10. And because the antiproton has the exact same mass as the proton, it will also have a rest energy of 1.5 times 10 to the minus 10. So what's going to happen is this total energy, which is the sum of the energy of the proton and the antiproton, will get converted into the energy of both of the photons combined. So each photon is going to get released with an energy of 1.5 times 10 to the minus 10 because there's two of them. So the energy gets shared equally between them. So in this case, when the initial speed is equal to 0, the total energy before the collision is equal to the total energy after. And the total energy before the collision is simply equal to 2 times the rest energy of the proton, which is equal to the total energy after the collision, which is the sum of the energy of each individual photon. So you can work out the energy, E photon, for each photon, which will be half of that of the total initial energy, or simply in this case equal to the rest energy. Let's look at another case. This time let's say we have an electron and its antiparticle, which is the positron, and they collide with each other. But this time, this positron has an initial speed of 0, but the electron has some speed, let's say 3 times 10 to the 6 meters per second. As you would expect, they will collide and two photons will get released. But this time, the total energy of both photons is going to be equal to 2 times the rest energy of the electron, because the rest energy of the positron is equal to that of the electron, but also the kinetic energy of the electron, as this here is the total initial energy. Now, pair production is simply the opposite of annihilation. This time you get a photon, and this photon is carrying some energy. And what happens is this photon then gets converted into a particle, let's just say it's a proton, and an antiparticle, which is the antiproton. And this typically has to happen near a nucleus in order to conserve momentum. But as you can see here, the energy of the photon is now converted into the rest energy of the proton times 2 because there is a proton and an antiproton, plus the total kinetic energy of both particles summed together after the collision. So the definition of what pair production is when the energy of a photon gets converted into matter and antimatter. And this will only happen when the photon has enough energy to create matter and antimatter. Now, the best piece of advice I can give you after watching that video is to go off and practice some past papers or topic questions. These are single-handedly the best way to help you commit the content you've learned to memory. Obviously, go and do all the YouTube stuff of liking, subscribing, and if you found this video helpful, feel free to go and watch any of my other ones.